I hope now you might have understood how to write the SR latch program. Now let me show how you have to show your output. Or in that you might have written some table, the truth table, like truth table, characteristic table you might have written. From there also you can understand how the SR latch is working. So instead of that, what I will do, let me show with the waveform here how it is be working here in this program. First, let me show SR. Two inputs are there. So let me draw the inputs first. So what I will do, I'll consider this 0, first 0 will come, right? Okay, so first 0, 0, 0, 0, 1, 1, 0, oh, sorry, 1, 0, 0, 0, next 1, 1, 0. Okay. Okay, that is the first input. Then second input is 0, 1, 0, 1, 1, 0, 1, 1, then 0, 1. That is like this. Next is clock signal. Clock signal should be like this. This is the clock signal. This is the clock signal. Now next is one more enable signal is right here. Enable signal. Enable is 1. So here I'll make it 0. Okay, so now let me take, this is nothing but yes, this is R, this is clock, this is enable. So now as per our program, first what it will do, it will check first enable. Right, first enable is equal to 1, yes, enable is equal to 1. Next what it will do, it will check for first enable is equal to 1. Yes, enable is equal to 1. Next we'll check for clock. Yes, clock is 1. When the clock is 1, next it will check for the input. My input is S equal to 0, R equal to 0. Now you see what happening here. S equal to 0, R equal to 0. My output is Q. Actually, I will consider here Q. Q bar, as you know, it is anyway, it's a complementary only. Let it be a draw only for Q. Now when S, R both are 0, 0, what will happen? As per our truth table, there is no change. No change means what? What is the previous value? What is the previous value? Now you think about like system. What is the previous value? It doesn't have any more previous value. Then automatically what will happen? It is nothing but a undefined actually. Previous value. So that is why what I will do, instead of this 0, 0 here, let me do small modification here itself. See, let me do a small modification in this figure only. Yes, I did small modification waveform now. Now you can see here, this is 0, now this is 1. Now, as per truth table, when S equal to 0, R equal to 1, what is Q? Q is 0 actually. So, the Q will be 0. See here, the Q will be 0 during which time? During this clock. See, it's a level, sensitive level. Only during this period only. Next, what you have to do? You have to check for next enable is you have to check for next clock signal here. Here. Clock equal to 1. In this, you have to see what is enable. Enable is 1 only. So still the enable is 1 means what will happen here at this time your latch will work. Then what about here in this period? So even though your input is changes, but the clock is 0 actually. So during the clock is 0, it will maintain the previous value only. That is 0 only. Till here it is 0 only. Next, you see, during this clock is equal to 1, enable also 1. What will you get now? 1, 1. So if it is 1, 1 in the sense, what is that? If it is 1, 1 means it's a undefined. It's undefined means we cannot predict what is the output. It can be high or it can be low until next. Until next. Until next. So what will happen? Till here, it will be till here. See? Till here, it is unknown only. It is unknown actually. See now still what I will do, let me increase this. Okay, let me increase this, then you may get a see, just I'm drawing randomly. Okay, so here I will make it the enable is high only. This one better, I will make enable till here enable high only, then this will be 0. I will make it. So now you see here, I will draw the diagram for or draw the diagram for here timing diagram. This is the timing diagram actually. This is the timing diagram. So this timing diagram only you have to see. Yes. So now you can see next. So till here it's fine. Okay. Even though for the next stage is here, next stage is here, right? See, next stage is this, next stage is this, next stage is this. Now till this stage actually it will be undefined only. Okay, next entry you see 0, 0 again. 0, 0 means what will happen? It's a previous study, previous undefined. Again will go as undefined only. So 0, 0 is undefined. So that is why what I will do instead of that, we need to do some changes here. Then I can draw the easily I can draw. So what I will do, let me do little bit change in the waveform. Yes.
So for third clock, S and R are 0 and 1, sir.
For third clock pulse, this one.
0 and 1 S.
0, 1. Sorry. Yes. 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 Yes, correct. Yeah. So third clock cycle. So up to this clock cycle only it is undefined. Fine. Yeah. Now you can see this. It is level high. 0 and 1 means what will happen? I'll get a 0. This 0 will be till where? Till the next level. In this level what? 0, 0. Again 0, 0 means what? Previous value, that is no change. Means now the previous value of Q is what? It is 0. So this 0 will maintain till next. This is what I said actually. That is a no change. Now again you see here it is 1. Logically 1, right? So logically 1 in the sense, now you see what happened here. Both are 1, 1. So again what will happen here? There will be a unknown value. Again here 0, 0, you will maintain only because this. So we have to draw the clock waveform properly. If you draw, I'll get all the combinations. So that is why normally you say your clock period should be, the frequency should be more actually. The time will be very, very less. Instead of drawing the clock as like this, how you have to draw the clock in the sense, you should draw like this. Simple I'm showing. I'm not going to draw. I will show how it is be. Instead of drawing the clock like this, you draw the clock as like this. Then I can get very easily if you draw the clock as like this. If you draw in this way, then it will be very, very easy for us to get all the outputs I'll get. But very important, the clock cycle will be like a duty cycle is 50%, your on time, off time will be equal. So that will be your clock period. Simply drawn here like this. So don't get like OA drawn in this way. So always that normally the clock cycle or clock pulse will be the period of 50% duty cycle. On time, off time is 50%, 50%. So like this only your output will get. See, based on like this only it will work. So from this simple I can say, so it is depends on how we are going to generate the waveform. That is very, very important. How we are going to generate. So instead of giving initially 0, 0, try to give the input as 0, 1. So next you give the input as 1, 0. Next you use 0, 0. Next you use 1, 1. After 1, 1, don't use once again 0, 0. Because 1, 1 is unknown. Again, if I use 0, 0 input means I'll get once again unknown only I will get. So better what you do after 1, 1 use 0, 1 better or 1, 0 you have to use. So you have to set or you have to reset. That is what happened in your characteristic table. I hope you remember, you might have studied in your logic design, the characteristic table you might return. So characteristical table means yes, you will consider like this, S or Q, that is present state. These three you will consider, then you will write the Q actually, that is the next state variable. Present state Q, the next state is Q plus. That will be the output of your S of latch. I hope you remember, you might have studied. I don't want to repeat that.
In case,
Yes.
case statement, we can use the output as vector, no sir. Q and Q bar, how we used for SR vector, we can use Q and Q bar.
Yes, you can use that also. You can use that is left to us only. Q bar if you use, what will happen directly here? You will write Q is equal to Q bar. You have to write. How will you write Q is equal to Q? Will write okay, Q bar you can write instead of this place, no? So I'll show that. If you use as vector type in the sense, if you use as vector type for vector type, if you are using for vector type, then like it will be like this only. As you say, 2 dash B00 is equal to Q underscore, just I'm taking the variable like this, Q underscore Q bar. This will be is equal to Q underscore Q bar. Here you might have done like this. Output colon 1 colon 0 1 colon 0 Q underscore Q bar. Is it clear now? You understood now?
So can we write two binary or decimal 0, 1?
Yes, it is left to it left to you actually. Even you can use binary, you can use a decimal also. You can use instead of this. So you are saying like this only. Even you can use like this 2 dash D0 straight away you can write. D0 is equal to Q underscore Q bar is equal to Q bar. That is how you can write, no problem. T. So it is representation. You are going to give the input in any format you can give. It is left to you only. It's not mandatory you have to give binary only. Even you can give in a decimal also. But you have to be very careful. The size of the bit you have to be very careful. Correct? See 2 dash. So that is very, very important because your input vector size is 2 only. You cannot go, if you write as like this will become as wrong. I hope you can understand that. 2D4. If I write like this will become as right or wrong. 2 dash D4 now. Wrong. It is wrong, right? Because 4, the decimal number 4 cannot be represented in 2 bits. We need at least 3 bits is required. So this becomes wrong. So up to maximum is 3 only. So you can write. So this specifies this 1, 2, 3, this 1, this 2, this 3 and all. If you want to write, very important, this you have to change. That is enough. If you change, it will be fine. Even you can give octal also, no problem. It will work. Is it clear now? Is there any other queries?
No, sir.
So now we are going to write the Verilog code for SR flip-flop. So first we start from module SR flip-flop, SR, comma, the clock signal. We are going to use the clock signal here. The output is Q. The input is we are going to use as a vector type. So 1:0 SR. The input is clock, output is Q. Next is register. Register also Q only. I'll use as Q. Next, now always after, now you see I'm going to introduce new concept because clock, right? So now what I will do here to write always at fast age. See, fast age clock. See what I did now? Additionally, I added simple thing here. See, this is what passage. Passage is a keyword. It represents the positive age triggered. So I'm not used any input here. You see, yes sir, I'm not used here because whenever the signal changes means what? Whenever this edges occurred, then this program will get executed. So irrespective of inputs. That is why I said in the combination circuit, all the inputs will come in the sensitivity list. But in the sequential circuit, only the signal which will change continuously. That is because your sequential circuits are based on triggering only. So the very important factor is your clock signal. So your flip-flop is purely depend on the clock signal only. So that is the reason I given passage clock. Even though if you write SR comma passage clock, that also is fine, but that is not the good way to write. So only better write like this. So that is the reason I'm showing here. Passage is a keyword. So let me show passage is for positive. Passage means positive clock cycle. Same the way negage. Negage means negative clock cycle. Negative clock cycle. I hope this is clear now. Okay. See, I use here comment. So means everything is commented. Keep it in mind. In a system, the comment line will show us like this. So better I show in system way. Yes, in system it will show like this only. Okay, now I'll go for begin. Now let me write what I will do. If enable is high, then case SR 2 dash B 00 Q is equal to Q. 2 dash B 01 Q is equal to 0. 2 dash B 10 Q is equal to 1. Then default Q is equal to X undefined. Next end case. Next is if enable is equal to 0 means Q is equal to 0. Then end if statement you are, that is this end, that is so if statement enable is equal to 1, this case will execute, case end case is over, else this is over, this end is for this begin, then finally you have to write as end module. See, this is the change, the difference between the latch and flip-flop program. You see the previously what you written? If enable is equal to 1. See here, flip-flop, correct? There is no enable signal here actually. Is any enable signal? I hope there is no enable. So I mistake written here. Yes, case. Then this won't come then. Yes, see. See the difference now? Completely this. Here we return. If enable means Whenever the enable is equal to 1, then only it will execute. But here I'm not specified anything here. Means you may think, where is the clock? See, I given here itself passage clock. Means what? Each and every time the system will check whether it is a positive clock or not. If it is a positive clock, immediately it will go inside. It will do the process. So the simple, I can say the operation, whenever first what you do, you have to check the edge of the clock. So how you have to check your output in the sequential circuit, especially flip-flops. How you have to check on the sense, first you check the clock cycle. First, whether it is a positive edge. Yes, if it is a positive edge, then you see what is SR value. Based on this S value, then you see what is the Q value. Next, that Q value will be maintained till the next edge of the clock. That is what I want to say here. So what I will do, let me show in the simulation here. I think that will be better for you. One simple simulation if I show, you may get clarity. Yes, now you can see this is a simulation of SR flip-flop actually. You can see here, here is showing yes. You see this, the timing lines and all showing here. I hope it is clear for you. I hope you might have understood this now, how we are getting the output. Is it clear? Later, if you consider, if you go for our as per our syllabus, we'll go on a little bit fast there actually. If you understood this concept, I hope now you might have understood how your SR flip-flop will work. Yes, is it clear?
Yes, sir.
Yes. So this is what's up about today. I hope what you can do now. I need you try. Okay, just to make a try. Same like this. Try to write other 3 flip-flops program. I want everyone to write the program for try. If not possible later, but I need you all to try. So take it as assignment. You take it as assignment and try. Nothing will happen if you try because they will get a more exposure on that. So take the assignment as D flip flop, D flip flop, then JK flip flop, then T flip flop. Try to write these three flip flop, even though else next class even I will 1 second just I will throw you light how to write. I will using simple way I will write this, even I will explain that. Just I need you need to try this one. Is it okay? Yes.
Yes, sir.
Yeah, is there any other queries?